useful for biologists. And of course, the novel computer science methods that are developed within the field of NLP and natural language processing to really push forward in order to make the process of putting data into databases that much easier. And of course, there's this big question mark in the middle of this slide indicating that people have actually done a lot of research in both areas, but as yet, we haven't managed to join the gap and bring things together. So the whole purpose of the meeting today is to really try and be practical about this and to ask the question of how can we really solve this problem. And so now I'm just going to go into a little bit of philosophy. Those of you who know me know that this is an aspect of the way in which I think and talk, so please forgive me about this. And so, of course, what we're going to try and do is introduce our own innovative strategy and build practical tools that actually live within the community. That's the kind of end product of how we're going to try and solve this problem. So, philosophically speaking, one way of thinking about this is that there are two separate scientific paradigms. Now, the definition of paradigm comes from Thomas Kuhn's original work back in the 1960s. And think of it just as a kind of way of thinking about it. Consider that there's the paradigm of computer science and natural language processing. And then there's the paradigm of bioinformatics. And the two are kind of separate. They both have their separate languages. They both have separate ways and practices of doing things. They have different value systems. If you're a computer scientist, you get tenure by presenting at ACL and being and producing really good algorithms and writing and developing really innovative computer science. But you don't get tenure for building computer systems that are useful. That's not your job. And yet, that's exactly the kind of thing that people in the other paradigm, in the bioinformatics paradigm, that's what they need. So consider that just think of this as two paradigms that are kind of separate from one another, requiring a bridge between the two. Those of you who know Stephen Johnson's work, he's a writer, and he wrote this wonderful book called Where Good Ideas Come From. And he talks about this concept of liquid networks. And there's a quote, he gave a TED talk at Oxford I think in 2010, where he talks about how ideas, the way in which we come up with ideas is not necessarily one person thinking about everything and coming up with a brilliant kind of stroke of insight. The way in which we come up with good ideas and with innovation is throwing everything together into a big pile and having connections be generally made in a very random but nonetheless constructive kind of way. And he says this environment is in fact the environment that leads to innovation. And so in a way, what I'm trying to really promote and talk about and what I'd like to invite you all to think about and talk about in this meeting is to think about how can we create that environment? How can we generate it? How can we make it work? And then finally, the final kind of conceptual basis of what it is I'm trying to create at this meeting is the process of reification. Now, to reify something is to take something abstract and turn it into a concrete thing. Now, within science, Bruno Latour, in his book in 1974, talks about how apparatus is a way of taking abstract scientific theory and turning it into a process that other people can use. So the example he uses is NMR spectrometry as a way of distilling 20 years of physics knowledge into a machine that can be used to do something effective and useful. So we need to think about how software actually is a process of reification that takes all of this wonderful research in mathematics and computer science and natural language processing and linguistics and such like, and can turn it into a real thing that we can then use. And of course, the vehicle for this is software. Trouble with that is that software in academia is, we're kind of constrained in some respects, largely because in order to build anything useful, you need a well-organized, well-trained set of programmers who are all able to command salaries of $150,000 or more in industry if they chose to kind of join the dark side and work for Google. Well, not that Google's the dark side, but to work for companies which are based upon profit and trying to make money for themselves. They can actually make a lot of money by doing this kind of work. And so trying to kind of build really polished, well-developed systems within academia is actually quite hard. It's relatively rare to find really production-level systems that are as well developed as Microsoft Word or any other kind of programs that achieve a difficult, highly engineered system, but developed within academia under academic funding mechanisms. So this is something that we have to change. And I'm actually committed to change this. This is the point of what we're trying to address here. In order to do this, how are we going to go about it? Well, our primary goal in this context is to take the task of biocuration and see if we can make it effective and productive. How do we transform the whole process of entering data from taking information from the literature and putting it into databases? That's the goal. Having said that, as a kind of subsidiary set of constraints and ideas, we want to also make software development cost-effective. How can we be competitive against people like Google and Yahoo and all of these other huge, large-scale systems that scale up brilliantly and can really execute what they're doing? How can we stop our programmers from being recruited by Google, who lives just down the street from us, by the way, and go and work for them? How can we make academic computer programming a productive and useful thing to do? And of course, the goal of what we're trying to do as academics, as scientists, is to really impact high, very important problems that cause great loss of life and cause great suffering. Can we actually make a difference there? And then finally, of course, it's very important to retain the inquisitive, fulfilling, fun, interesting aspects of being an academic. We want to live in the world of ideas. We want to be able to kind of share information freely. We want to be able to do this kind of stuff. And so I'm going to present work today which really talks about how open source programming is a way of doing that. Now, so that's the kind of philosophical background of the meeting. From an organizational point of view, I have some suggestions as to ways in which you can contribute, ways in which you can participate today, things that I think will make your participation more fun for you and probably more constructive for everybody else. So as a scientist generally, please think about the idea that we have two separate paradigms, and we currently have not figured out how to bridge the two. So in other words, we have to be creative. When someone from the NLP community, and so we have to be both creative and brave. You can't be intimidated by an NLP person standing up and saying, okay, this is what I do, and then we can't step back from that and go, oh, I don't understand any of that. That's too difficult. So please engage. You know, let's step out into uncharted territory and see if we can find a meeting point between the two things. As a natural language processing scientist, in general, I'm going to say, please wrap your code in a way that makes it accessible and useful to other people. That's a general kind of principle. And of course, speaking somewhat selfishly as the project leader for the SciKnowMine project, I would like you to make your code available to me so that I can use it. As a biocurator or a bioinformatician, please be prepared to be an early adopter. Use systems that don't work very well. Give feedback to the people who are generating the system so that they can improve it for you. Don't wait. Don't be so stressed about the work that you're having to accomplish that you're not prepared to kind of reach out and help the computer scientists and the informaticians develop novel solutions for you. And also, I would say, please don't let past failed promises stop you from participating and going forward in the future, because there's a lot of that as well. And then finally, as a tool builder, as someone like me, someone who's interested in building programs and software, we need to be prepared to compete with one another openly in such a way that we share designs and concepts, but we're not so competitive that we prevent other people from participating, but we don't insist that everybody be so open with us that they have to adopt our code. For me, it's okay if other people use other systems, but I think it's more interesting if we can work together and just tell me what you're up to so that I can try and compete and we can see what we can do. So this is the kind of the perspective of how I like to see us kind of do stuff going forward. Okay, so let's go over the plan for today. You all have a pamphlet with our Information Sciences Institute logo on it. Oh, by the way, for those of you who don't know, ISI is the large stripy building on the right out the back there. So you have a beautiful view of our office as it appears. So this is part of the reason why we chose this venue, is spectacular view, but also we can see where we come from. I actually included, I asked all the speakers to provide bios, and for those of you who wrote the bio and then saw that I didn't include them in the meeting handout, please forgive me. I wanted to make this as kind of brief and easy to read as possible. So the abstracts should give you an idea of what individual speakers are talking about, and I will do my best to try and introduce in each of the speakers as they come up from the bio notes that they gave me. Today, just to give you a kind of high-level overview of the plan, we're going to start off with me talking about SciKnowMine, the SciKnowMine project specifically, to give you a kind of high-level view of, first of all, what the context for the meeting is, but also we're going to talk a lot about the Mouse Genome Informatics project, because they were the ones who were collaborating with us most to start with, and so that kind of sets the scene for where it is we're trying, what kind of work we're trying to do. Then we're going to, after the first session, so each session is going to be about an hour and a half long with 3 talks. Then we'll have a break, and then we'll move forward again. So, and you'll see we actually have quite a packed program, so I'm going to be a little ruthless about time. We actually have an iPad here that with a timer on it that will flash red at the appropriate time, and I'm afraid that'll be that. Okay, so, and each talk will be 25 minutes long. There'll be 5 minutes to turn things around and change things over. And in that time, we'll have questions from the floor so that people can ask and obviously do that. The meeting is being streamed as we are speaking, and we're recording it as well. So we're going to put this up on YouTube later on. So in the spirit of openness and general hackery, we're going to try and make this as kind of open and presentable as possible. The second session is going to be talking about some biomedical databases. Other than MGI, they're going to be presenting technology and different database approaches that involve I think we have Reactome, we have the Rat Genome Database, RGD, and we have Jim. I'm not sure how to introduce your database, but you will tell us more about it at the time. Then in the third session, I think just after lunch, in fact, we'll have some experts from natural language processing talking about the technology and the science underneath some of the more cutting-edge kind of approaches that we're using. And we'll be hearing from Alan Ryloff and James Gum and I forget who the third person is, I'm sorry. And of course, Maximilian Hausler will be talking then. And then we'll actually, so that kind of covers both paradigms. And then in the last session, the last kind of formal presentation session, we'll be talking about technological approaches to bring things together. We have a couple of presenters who are talking about these kind of high-level interactive kind of frameworks where we can start to think about synthesis and bringing things together in a constructive way. And then finally, I'd like to finish the meeting with a discussion. So you'll probably be all quite tired by that time. Please hang in there. I think this is the place in which we can actually make some progress. I'd really like to hear people's opinions and ideas about ways in which we can constructively bring everything together and make things work.